Hi, algebra students. I hope you guys are well. I was looking ahead to what you're doing this week, and the lessons are getting pretty challenging, so I just wanted to make you this video and help you out. I'm hoping that you'll actually watch this video before you do Wednesday's formative assessment. I'm actually going to go over a couple of those problems, so this should help you out if you are watching this first. So let's look at a few problems that you'll see this week. So on the very first lesson, what they're going to do is remind you of exponent rules that you're already familiar with. So hopefully you guys remember that anything raised to the 0 power is 1, a variable or a digit. So 3 raised to the 0 power is 1, -10 raised to the 0 power is 1, so on and so forth. Negative exponents basically make you turn whatever is raised to the negative exponent, whether it's in the numerator or denominator. In order to make that exponent positive, you're going to flip over the line. So if it's in the denominator, then to make that exponent positive, you flip it up to the numerator, and vice versa. If you have a negative exponent in a numerator, to make it a positive exponent, you flip it down to the denominator, just like this example right here. The product of powers, so if you have two numbers that have the same base, like x times x, they have the same base, your answer is you keep that base and you add those exponents. So even if it's a digit, like the number, if I could find my little pen here. Where's my pen? There it is. So even if it's a number like 2 raised to the 2nd power times 2 raised to the 4th power, the exponents, the bases are the same, so you keep those bases. So this base is 2, you add those exponents and you get 6. And then of course you can simplify it from there. The quotient of power, so if you have two numbers that have the same base, whatever those exponents are, if they're being divided, you are going to subtract those two numbers. So if we have 4 to the 4th power divided by 4 to the 5th power, well, the rule says you subtract the number, so 4 minus 5 is -1. So now we think about our negative exponent rule. The way this is written, the 4 is in the numerator. To make it a positive 1, we flip it down here to the denominator. You can't have a blank in the numerator, so we have to put a 1. So 4 to the 4th power divided by 4 to the 5th power is equal to 1/4. Okay? All right, so power of a product. So if you have anything raised to an exponent, like even if you have 2 to the 4th times m to the 2nd raised to the power of 3, then everything in the parentheses gets multiplied. Every exponent in parentheses gets exponent. Let me start over. Every exponent in the parentheses gets multiplied by 3. So 4 times 3 is 12. So 2 to the 12th times m to the 6th. 2 to the 12th times m to the 6th. That's power of a product. All right, power of a quotient. So if you have a fraction, that x is raised to the 1st power, the y is as well. So everything in those parentheses gets multiplied by n. Power of a product, that's very similar to what we talked about right here. Power of a product. Same thing, I guess, as this. Power, it is the same thing. I don't know why it's on there twice. All right, so here is the new rule that you guys have not yet seen. So fractional powers. It says fractional powers, where a number is raised to a fraction, it can be converted to a radical. Remember what a radical looks like? It's a square root. Why am I way down there? It's a square root symbol. That's a radical. The numerator becomes the exponent, and the denominator becomes the index of the radical. For example, look at my number right here. So 2 raised to the 1/3 power. So the 1 stays with the 2. The 1 becomes the exponent to the 2. It goes inside that radical, and the denominator becomes the index. So you would say, what is the 3rd root of 2 to the 1st power? What is the 3rd root of 2? because 2 to the first power is just 2, correct? So that's what happens to that fraction. You divide it up, the numerator stays with the base, and the denominator becomes the index of the radical. So how can I rewrite 3 raised to the 1/3 power? Well, the 1 becomes our exponent, and the 3 becomes the index. So the third root of 3 to the first, well, of course, 3 to the first is just 3. So that's our final answer. All right, what about 4 raised to the 2/3 power? 4 squared is under the radical. It's our radicand, and our index is a 3. So what is 4 squared? Isn't 4 squared 16? So the cubed root of 16, the cubed root of 16. Now, how about this one? What's 5 squared? So we're going to leave 2 with the 5. It becomes the exponent, and our index is a 7. So the 7th root of what is 5 squared? 25. So that's how you convert all of those. So now we're going to use all of those exponent rules all together to solve problems in this first lesson. So number 1, which this is the problem for number 1, it says your final answer should be in radical form, like we just converted that, right? So here we have 2 numbers that have the same base, a 4 and a 4, and they have exponents and they're being divided, or the bases are being divided. So what is the rule when you have 2 numbers with the same base? What do you do with their exponents? You subtract them. So I'm taking the exponents and I'm subtracting. So 5/6 minus 1/6 is 4/6. And 4/6 simplified is 2/3. So I'm taking 4, which is our base, to the 2/3 power. So how do I write that in radical form? Well, the 2 stays with the 4, so 4 squared. And that denominator becomes our index. So the cubed root of 16. The cubed root of 16. That is the answer to number 2. All right, number 3, we have 2 numbers that have the same base that are being multiplied. So the rule for their exponents is you add them. So 1/6 plus 1/3. To add fractions, we must have common denominators. So 1/6 times 2/2. 2 times 1 is 2, and 3 times 2 is 6. So we add our numerators, we get 3/6, which is equal to 1/2. All right, so all we've done so far is add those exponents. So now we have basically 3 to the 1/2 power. Well, the 1 stays with the 3 under the radical, and the 2 becomes my index. So basically the answer is the square root of 3, square root of 3. And really, even with square roots, I don't have to have the 2. So best answer is square root 3. All right, number 4. First thing we're going to do is make the bases the same, and then we're going to solve. So I have a base of 6 and a base of 36. Well, isn't 36 the same thing as 6 squared? So if I made 36 6 squared, then my basis would be the same. So I'm going to take 36, I'm going to write it as 6 squared. That's 36, right? But it's 36 raised to the 1/4 power. So now I have a power raised to a power. So what do I do with the exponents when I have a power raised to a power? The rule is I multiply the exponents. Well, 1/2 times 2 times 1/4. What's wrong with me? 2 times 1/4 is 2/4, which is equal to 1/2. Oh my goodness, my brain just stopped working. It's right after lunch, you guys. That's my excuse. So basically that whole thing right there, I'm rewriting that whole thing as 6 to the 1/2 power because of all this math right here. 6 to the 1/2 power times 6 to the 1/2 power. Well, what do I do with the exponents when I have 2 bases that are being multiplied? The answer is I add them. So 1/2 plus 1/2. If you eat half a candy bar and I eat half a candy bar, how much of a candy bar do we eat? One candy bar. Well, what is 6 to the 1st power? It's just 6. So the answer is 6. So 36 to the 1/4 power times 6 to the 1/4 power is 6. All right. Now, let's look at number 5. And by the way, your calculator will do all this for you if you'll type that in there like I just did. I like to always double check my answers. But you need to know how to do it even if with a calculator or not, you need to know how to do it. So I'm making a fraction, 36 1/4 power times, and so I type it in just like you see it on the screen, 36 1/4 power times 6 to the, oh, I didn't have an exponent. When I did 36 to the 1/2, I didn't make it an exponent. Whoops. My bad. Now it looks right because my exponent's little. See that? Times, I'm going to arrow right, times 6 to the caret button, and then my fraction button, 1/2. So that's what it looks like. And my answer is 6. So it's good to check myself. I need to know how to do it without my calculator, but it's good to have the calculator to check myself, make sure it's right. All right, so look at number 5. So this is a little confusing. We got 2 radicals. So ignore the big radical for a second. So we know that's a square root, right? But anyway, we're going to ignore that. So the first thing we're going to do is think the opposite of this step. So going from this step to a radical, we would use that 1, keep it close to the 6, put it under the radical, and make our index a 2. Well, we're ignoring that big radical right now. We're just looking this side right here. We're just thinking of how to write this as a mixed number, or not a mixed number, but a number raised to a radical. So my 5 is to the first power, correct? So that means my numerator is 1. And that 4, that is the index, becomes my denominator. So this, in this form, these are equivalent right here. So now we know that the square root, so whatever is under the radical, the denominator of our fraction is going to be a 2. So basically, the square root of a number is a number raised to the 1/2 power. It's the same thing. Okay, so now I have a power raised to a power. So what do I do with those fractions? I multiply them. I should have said, what do I do with those exponents? The answer is I multiply them. So 5, and then 1 times 1 is 1, and 4 times 2 is 8. And that is my final answer, 5 to the 1/8 power. All right, let's see that one step at a time. So basically we take the 4th root of 5, and we raise it to the 1/2 power. And that 1/2 power is taking that square root. Anything raised to the 1/2 power is basically the square root of that number. And then step 2 is we turn the 4th power of 5 into 5 to the 1/4 power. We're going to multiply it by 1/2, and we get the answer 1/8. All right, so you guys, oh, and I didn't finish it. So finally, the final answer is the 8th root of 5, the 8th root of 5, because our 8 becomes our index, and the exponent is a 1. So let's take that example and try number 6. So number 6, same thing. We're going to ignore that huge exponent at first, and we're just worried about the cube root of 7. So we're going to think of that as 7 to the 1/3 power, 7 to the 1/3 power, and then the square root of that is a number raised to the 1/2. So now we have 7 to the 1/3 raised to the 1/2. So what do we do with those two exponents? Power raised to a power, we multiply them. So 1 times 1 is 1, and 3 times 2 is 6. And then finally, we write that as a radical. The 6 becomes our index, and 7 to the first power goes under the radical. And so my final answer is the 6th root of 7. The 6th root of 7, okay? So basically, think of that as a 2. Isn't 2 times 3, 6? We know that's a 2, right? Isn't 4 times 2, 8? 4 times 2 is 8. So hopefully you'll see a little pattern emerging there. Okay? I know these are a little tough and confusing, so you have to go through them. You need to go through the lesson. You need to look at it very closely. You need to watch every video. You need to do every single practice problem. Try it on your own and then check your answers to grasp this. This is a lot of stuff, you guys. All right, so number 7, we have two numbers that are being multiplied. So let's write them as exponential, in their exponential form, and then see what happens. So we know the square root of 5 is the same thing as 5 to the 1/2 power. So the square root of 5 is 5 to the 1/2 power times, what would this be? Our exponent under the radical is a 1, so that 5 becomes the denominator. So 5 to the 1/5 power. Right? So these two bases are being multiplied. What do we do with their exponents? We add them. So 5 and 2, our least common denominator is going to be a 10. Let me ignore that for a minute. So I'm adding 1/2 plus 1/5. So we're going to use 10 and 10. So 2 times 5 and 5 times 2. So 5 times 1 is 5 and 1 times 2 is 2. So we get 7/10. So basically 5 to the 1/2 power times 5 to the 1/5 power is 5 to the 7/10 power. So that the denominator becomes the index to my radical. The 10th power of 5 to the 7th power. Well, we can figure out what 5 to the 7th power is on our calculator. 5 raised to the 7th power is a great big number. So it's the 10th root of 78,125. Okay, so depending on what the directions say, either the answer is this, or if we want to go a step further, it's this. Okay. All right, look at number 8. So we have the same base being divided. What's the rule for their exponents? We subtract them. So we're going to do 2/3 minus 1/6. Well, our least common denominator is 6. So 3 times 2 is 6. We're going to multiply 2 times 2 is 4. So 4/6 minus 1/6 is 3/6, which is equal to 1/2. So we have 49 to the 1/2 power. Well, 49 under the radical, 49 to the first power, and then the square root of that. Well, we know this answer, don't we? What is the square root of 49? The square root of 49 is 7. So 49 2/3 divided by 49, I didn't say that right. 49 raised to the 2/3 power divided by 49 raised to the 1/6 power is 7. That's the answer. All right, look at number 9. Now the way these are written, these do not have the same base. So you can't multiply this unless you make them the same base. Well, we can't make 2 as 16, but we can make 16 a 2, a power 2 to this what power? So I know that 2 to the 3rd power is 8. So isn't 16 2 to the 4th power? So 2 times 2 times 2 times 2 is 16. So 16 rewritten as an exponent is 2 to the 4th power. But it's not just 16, it's 16 raised to the 1/4 power. Well, power raised to a power, we multiply their exponents. So 4 times 1/4 is 1. So basically, all of this is equal to the number 2. 2 to the first power times 2 to the 3rd power. So we have two numbers with the same base. What do we do with their exponents? The answer is we add them. So 3 plus 1 is 4. So our final answer is 16. So that's what this equals right here. And if you plug that in your calculator, you're going to get 16. All right. All right, let's look at number 10. Let's do the same thing. So we have 2 to the 7/8 power divided by 2 to the 1/4 power. So what are we going to do with our exponents with the same base that are being divided? we subtract them. So 7/8 minus 1/4. Well, we're going to turn 1/4 into 2/8. So then we get 5/8. So basically we have 2 to the 5/8 power. Well, what happens there? Our 5 becomes our exponent. So we have 2 to the 5th power. And we want to know what is the 8th root. So what is 2 raised to the 5th power? 2 raised to the 5th power is 32. So basically our answer is the 8th root of 32. And that might actually be a whole number. So remember how to use your second power. You're going to use your second power. Wait, let me clear this. So if you use the little caret button, you use the second button. Actually, let's do it a different way. Let's go ahead and hit 8 on our calculator. And then we're going to hit the second button. And then we hit the caret button, which is this. And then look at our little 8. It just became very tiny. That's the 8th root of 32. Oh, it's not a whole number. It's a decimal. So we'll just leave it in this form since it's a non-terminating decimal. So that's the final answer. All right, number 11. Explain how these two, explain how this is equal to 2 squared. Well, we're dividing two numbers. Well, right now the two numbers don't have the same base, right? So we're going to rewrite 8 as a power of 2. So 2 to what power equals 8? So 2 times 2 times 2 is 8. So 2 to the 3rd power, whoops, oh my goodness. 2 cubed is 8. So basically I could write 2 to the 5th power divided by 2 to the 3rd power. Well, now I have the same base that are being divided. So what do I do with their exponents? I subtract 5 minus 3. And that's how that equals 2 squared. Ooh, what a mess. All right, and then look at number 12. Rewrite the radical as an a rational exponent. A rational exponent. So they just want us to take this and turn it into one of these things right here, which is easy. Now we've done this so many times. So our 5 is our numerator and the 4 is our denominator. So that's the answer. I think that's the last one, isn't it? Oh no, we have a couple more. All right, did y'all understand that? 7 raised to the 5th, the 5/4 power. All right, rewriting a rational exponent as a radical. All right, so first of all, we have a power raised to a power. So the directions say we multiply 3/4 times 2/3. Those 3 disappear, they cancel each other. So basically 3/4 times 2/3 is 1/2. Because I would have 6/12 anyway. So how do I write 5 as raised to the 1/2 power? I would raise it as the square root of 5. Square root of 5. And then number 14, a rectangle has a length of 3, the cubed root of 81, and a width of 3 to the 2/3 power inches. Find the area of a rectangle. So how do you find the area of a rectangle? You multiply length times width. So we're multiplying the cubed root of 81 times 3 raised to the 2/3 power. Well, 81, the cubed root of 81 is going to be the same as 81 to the 1/3 power times 3 to the 2/3 power, right? But we got to have the same base. In order to add those exponents, we have to have the same base. So 3, surely I can rewrite 81 as a power of 3, right? So I know that 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So 81 is the same thing as 3 to the 4th power. So 3 to the 4th power raised to the 1/3. So I have a power raised to a power, so I'm going to multiply those exponents. So I'm going to multiply 4 times 1 is 4, and 3 times 1 is 3. Now I have this same, uh-oh, that should be a 3. Hold on, we're almost done, everybody. We're almost done. Well, there we go. Now I'm ready to simplify. Now what can I do with those exponents? I'm going to add them. So 4, 5, 6. So I have 3 to the 6th third. Well, what is 6 thirds? It's 2. So basically my answer is 3 squared. What is 3 squared? 9. So the answer is 9 squared units, 9 inches squared. Okay, that would be the area of my rectangle. All right, I think that's it. Yep, that's it, you guys. So like I said, a lot of material. That's just for your very first lesson. It's not, the first lesson to me is the hardest one of this unit. So that's why I just wanted to make this for you. Hopefully that helps you. I'm gonna go ahead and share this with you. Hopefully you'll watch it first on Wednesday, and then you'll have a little better, easier time when you do your work. Okay, and then we'll get together for a few minutes on Thursday to see if you have any other questions. All right, you guys, I'll see